Welcome. Today we're going to discuss 4 types of angles. On this side of the page we have vertical and adjacent angles. This has to do with the location or placement of the angles. On the back we'll talk about complementary and supplementary angles. Those have to do with the degrees of the angle measures and how they relate to each other. So let's get started. For vertical angles are going to be 2 angles that are formed by 2 straight intersecting lines. Now specifically, these are going to be the 2 angles that are across from each other. So if we're looking at this diagram here, I can see that angle ACB, this top angle, and this lower angle, angle DCE, are angles that are directly across from each other when they're formed by these 2 lines that intersect. And something else that you'll notice if we're comparing these 2 angle measures to each other is that they have the same degrees. And the same is also true for this other pair of vertical angles. Angle ACD is opening up on the left side, and angle BCE is opening up over here on the right side. And they also have the same degrees as each other. That's because vertical angles are always congruent to each other. So congruent is a way to describe objects or shapes and indicate that they have the same shape, same size, same measurements as each other. It's a little different than saying that 2 things are equal to each other because we're talking about objects. So if, for example, I'm comparing these binder clips, it's a little awkward to say that these binder clips are equal to each other. I would have to be talking about a measurement. So they have equal weight, or they can hold equal amounts of paper, or they have equal lengths to each other. However, if I'm talking about this object, they have the same shape, the same size, so we can say that these objects are congruent to each other. So when we're talking about angles, we don't really talk about angles being equal to each other, we talk about them being congruent. So in this example here, we can identify that we have the angles formed across from each other, like angle ACD and angle BCE. That is one pair of vertical angles. It's important to be careful when you're naming angles because we want to make sure that we're tracing along the edges of that angle. So we start with a point on one ray or one side of the angle, and then we name the vertex or the corner of the angle, and then we name a point on the other side of the angle. We could also name this in reverse, so for this angle ACD, we could name it angle DCA. That also works as well. And likewise for angle BCE, we can name it going in the reverse direction, so angle ECB. They both talk about the same angle. Because all of these angles have the same vertex C, we have to make sure we specify which angle we're talking about by naming points that are on the edges or the sides of the angle. Our second pair of vertical angles is the top and bottom here, so we have angle ACB and angle DCE. They are also vertical angles with each other. Now the symbol that we'll see come up later on for congruent looks similar to an equal sign. It's going to be an equal sign with a squiggle on top. So it's going to look like this. This right here is the symbol for congruent. It's an equal sign with a squiggle on top. All right, so let's look at 3 examples relating to vertical angles. So first of all, here we're asked to determine if the 2 labeled angles, so angles 1 and 2, 3 and 4, 5 and 6, are or are not vertical angles. Well, I find it helpful to trace the angles and look at their sides. If we're looking at vertical angles, for example, over here we had angles ACB and DCE, we can see that the sides of the 2 angles are created by these 2 straight lines. So this side of this angle continues to create this side of this angle, and this side up here of the top angle extends down here to create the side of the lower angle. So we can see that these angles, the pink angles and the orange angles, are both created when these two straight lines intersect. If I look over here, I can see that the sides of this angle and the sides of this angle do not create two full lines. So they share this side here. They need to be across from each other. So these are angles that are next to each other, not across from each other. So even though there are vertical angles that exist in here, the labeled angles 1 and 2 are not a pair of vertical angles. So we can say no, because they are not across from each other. So we can say that because these angles are next to each other, not across from each other, that they are not vertical angles. If I look at this next example here, we have angle 3 here and angle 4 over here. These angles look to be kind of across from each other. However, if we're looking at the sides of the angles, I can see that this lower side of angle 3 extends straight out to create angle 4, so that looks good. And this upper side of angle 3 bends and then comes down to create angle 4. So this here is not a straight line. So even though these are across from each other, they're not formed by two straight intersecting lines. This one is broken. So here we would say, no, one line is not straight. And if we look at our final example here, we can see we have angle 5 over here and angle 6 over here. If I'm looking at the sides of the angles, I can see that this side of angle 5 extends to create angle 6. This side of angle 5 extends to create angle 6. So these are formed by two straight intersecting lines. And these angles are directly across from each other. So yes, these are vertical angles. So yes, these are vertical angles. Now, the nice thing is, if we can identify vertical angles, it's going to be very easy to calculate what those angle measurements are. And that's because vertical angles are congruent. So that means the degrees of the angles are equal to each other. So over here, we're asked to find the measure of angle CED. Well, if I trace this angle CED, I can see that's this angle over here. And if I'm looking in the diagram, I can tell that this is a vertical angle with angle AEB. So that means, because they are vertical angles, that they have to have the same degrees, because the vertical angles are congruent. So that means we can say the measure, or M, of angle, so we put the angle symbol, CED, equals the degrees of its vertical angle, which is 50 degrees. And if we look down here, we can see that if we're asked to find the measures of angles 1, 2, and 3, well, if I'm looking at my diagram, I can tell that this angle is a vertical angle with angle 2. So we know that they have to have the same degrees as each other. So that means the measure of angle 2 has to be 35 degrees, because they are vertical angles with each other. Now, I find it helpful in cases like this to document this information in the diagram, so that if I look back at it later, I can see that, ah yes, this is the angle that's 35 degrees. Now, we just need to figure out the measures of angles 1 and 3. Well, if we look at this diagram and ignore half of it, for example, I'm going to cover up angles 2 and 3, we can see that this 35 degree angle and angle 1 together create a straight line. Now, the measure of a straight line is always 180 degrees. So that means if you add up the pink angle plus angle 1, it needs to together equal 180 degrees. So that's exactly what we're going to say. We'll say 180 degrees equals the 35-degree angle plus whatever the measure of angle 1 is. We don't know what that is yet. We'll solve for that. So I'm writing this as the measure of angle 1 instead of using a variable like x or m or t or something like that. But you could use a variable instead. So we need to solve to get the measure of angle 1 by itself. So I need to get rid of this 35. I can do that by subtracting 35 from both sides. And when we do that, 180 minus 35, that will give us 145 degrees, and that is equivalent to the measure of angle 1. So that means we've now figured out that the measure of angle 1 is 145 degrees. And if the measure of angle 1 is 145 degrees, its vertical angle is also angle 3. So that means we now also know that the measure of angle 3 has to be 145 degrees as well, because its vertical angle, because it is congruent with its vertical angle. So here, it was mostly identifying and a little bit of setting up and solving an equation. Now sometimes we have a diagram where things look just a little trickier. Here we're asked to write and solve an equation to find the value of x. Well, if I'm looking at the angles that are identified here, we have this 78-degree angle, and we have this angle down here. These angles are formed by two straight lines intersecting. They are across from each other, so that means these angles are vertical angles. And because they are vertical angles, we know that they have to be congruent. So they have to have the same or equal measures. So we can set these angles equal to each other. So we can say that we have 78 for this orange angle, and that has to be equal to whatever this expression is here, 5x minus 2. Well, now that we've built an equation, we can go ahead and solve to figure out what x has to be. So first, I'm going to get rid of the constant by adding 2 to cancel out with the negative 2. So I'll be left with 5x on the right side. On the left side, 78 plus 2 will be 80. Now I need to go ahead and get x by itself. So I can do that by getting rid of this 5. Right now the 5 is being multiplied to x, so I can undo multiplication by dividing. And 80 divided by 5 will give us 16. So we figured out that x has to equal 16 for this diagram to be correct. So with vertical angles, we're checking to see if the placement of the angles are directly across from each other and if they're formed by two straight lines that intersect, no bent lines or broken lines. The next type of angle that we're going to look at is adjacent angles. Now these are two angles that are side by side or next to each other. That means they have to have a common or shared ray because the sides of the angles are rays. They start at a point and extend out forever. And they also have to have a common endpoint or vertex. So we use both of these descriptions to describe basically the corner of the angle. So in this example here, we can see that we have angle A right here, and we have angle B right here. We can see, sure enough, that they both have the same corner, the same vertex, and they both share this middle side here. So that means we can say that angle A and angle B are adjacent angles, meaning that they are next to each other. Now, unfortunately, when we have adjacent angles, we do not necessarily know anything extra about their angle measures. Angle A could be really large and angle B could be really thin. We don't know if they have to add up to equal something necessarily or if they have to be the same measurement. All that this is telling us is that they are located next to each other on the diagram and they have the same vertex. So if we're looking over here at these diagrams, we need to identify which of these are and are not adjacent angles to each other. So I find it helpful to go ahead and trace all of the angle A's in one color and all of the angle B's in a different color. Over here we have angle B. We'll do that in green. So if we're looking at this, we need to check and see that the two angles have a common ray or side, and they have a common endpoint or vertex. So if we're looking here, I can see the two sides of angle A are not shared with either of the two sides of angle B. They do have the same vertex, the same corner, but in this case, they are not adjacent. Because there is no shared ray or side. If I look over here at example 8, I can see that angles A and B, they share this ray here in between them. It's marked both with green and blue, and they both have the same vertex or endpoint, so these are adjacent. We can say yes, they are adjacent. If I look down here at example 9, I can see that, again, they both share the same vertex, that's this point here, and they both share this slanted side here. It's marked both with blue and with green, so these are also adjacent angles with each other. And over here for example 10, I can see angle A and angle B, they both have this shared vertex here, this corner, and they both share this side here, so these are also examples of adjacent angles. All right, next up, in this diagram, we are asked several true or false questions identifying if different pairs of angles are or are not adjacent to each other. So let's look at this. Again, I find it very helpful to trace the angles either with pencil, or in this case, I'll be using highlighters, just so that it's easier to see how these angles relate to each other, because there's a lot of different points going on in the diagram. You are welcome to use your pencil if you want. I just recommend making sure you don't mark up the diagram too darkly so that it makes it hard to read the points later on, since we have to use it for several questions. So first we have angle AGF, so that's going to be this angle here, AGF, and angle AGB, are adjacent angles. Well, if I'm looking at this, they have the same vertex at G, and they both share side AG, so that means that, yes, they are adjacent. So this is going to be true. So, and that's specifically because they share ray GA, so we can label it as GA with the little arrow going across it. All right, next up, we have angle EGD, so that's going to be here EGD, and angle BGC, so we have BGC, are adjacent angles. Well, if I'm looking here, I'm comparing the pink angle and the orange angle. They both have the same vertex, G. However, if I look at the sides of angle BGC and I look at the sides of angle EGD, there are no sides that are shared between the two angles. So in this case, they are, this is false because there is no common or shared ray. All right, and lastly, we have angle FGB, so that's going to be F here, G, and then that comes up here to B, so it's going to be that angle. And angle BGC, so that's going to be here, so BGC. So if we're comparing this, the yellow angle and the purple angle, we can see angle FGB and angle BGC. They have the same vertex and they both share this ray GB. This creates a side for both of the angles. So this is true. And that's because they share ray GB, the arrow on top. So when it comes to identifying adjacent angles, you need to make sure they have the shared vertex and that they share a side. If there's a gap between the two angles, they're not going to be adjacent. Next, we're going to flip this and look at some examples having to do with angle measures. So when we're talking about complementary angles, these are two angles that together add up or have a sum of 90 degrees. So in this diagram, if we're looking at this, we can say that angle WXY and angle YXZ down here we can see that 65 degrees plus 25 degrees, that adds up to make 90 degrees. So we can say that these two angles are complementary to each other. Now, in this diagram, there's also another special angle, angle WXZ. We can make a note up here, angle WXZ. This is a right angle. And that's because we can see that this box right here, this box always indicates that an angle is 90 degrees. So we can see the angle that this box connects. It's connecting this vertical side here and this horizontal side here. So that's the angle that is 90 degrees. So angle WXZ is a right angle or a 90-degree angle. So the two smaller angles that this is broken up into, those smaller angles are what we describe as complementary to each other. So if we know one angle measure, we can find its complement, or what other angle it is complementary to, because we know together they have to add up to make 90 degrees. So if we look over here, if we know the measure of angle A is 20 degrees, we can set up an equation where we know the measure of angle A, which is 20, plus this mystery other angle, we'll just say its measurement is x. They have to add up to equal 90 degrees. So to solve for x, we can go ahead and subtract 20 from both sides, and we get that x has to equal 70 degrees. So that mystery angle has to be a 70-degree angle if angle A is 20 degrees. If we try to do the same here for part B, if the measure of angle A this time is 120 degrees, well, let's try setting up an equation for that. 120 plus x equals 90 degrees. Well, to solve, we'll need to subtract 120 from both sides. 90 minus 120, that will give us negative 30 degrees. Now, if we stop to think about this, is it possible to draw an angle that's negative degrees? You could argue that possibly that might be the case, based on the direction that you move, but that's not something that we really care about in 7th grade. So this actually is not going to be possible for us. We could draw an angle that's 30 degrees, but then if we add that together, it would create 150 degrees altogether, and that's too large. So this actually is not possible. So we'll say for part B, there is no complement. And that's because the first angle is too large. It is not possible to add 120 to another angle measure and get 90 degrees because we do not have negative angle measures. Our next example down here for number 2. Now we can see that because there is this box shown here, that this larger overall angle is a right angle. So that's why we know that these two angles together have to be complementary. So we can set up an equation where we say 90 equals the 44 degrees plus whatever angle A is, plus the measure of angle A. So to solve, we can subtract 44 degrees from both sides of the equation. 90 minus 44, that'll leave us with 46. So the measure of angle A has to be 46 degrees. Up next, we're asked to identify if this set of angles are or are not complementary. Well, let's check and see. If we add their angle measures up, 45 degrees plus 45 degrees, that equals 90 degrees. The definition of complementary angles are two angles whose measures have a sum of 90 degrees. There is no requirement for the angles to be adjacent or next to each other. So these two angles, even though they're not touching each other, they are still complementary because we only care about what their angle measures add up to. So here we'll say this is complementary. because the sum is 90 degrees. So it's perfectly fine that they are not adjacent to each other. That does not concern us. In this next one, it says angle X and angle Y are complementary. If angle Y is 32 degrees, then what's the measure of angle X? Well, if we know that they are complementary, that means they have to add to make 90 degrees. So we can create an equation based on that information. So we know 90 degrees has to equal this 32 degrees plus whatever the measure of angle X is. We don't know what that is. So we can go ahead and solve for the measure of angle X by subtracting 32 from both sides. So we'll get the measure of angle X equals 90 minus 32. That'll leave us with 58 degrees. So angle X has to be a 58-degree angle. All right, finally, over here, we can see some slightly more complicated diagrams. We are asked to write and solve an equation to find what X has to be. Well, if I'm looking at this diagram up here, the first thing that I notice is there is this box here. So this tells me that this larger angle here is a right angle. So that means these two smaller angles that together create the large angle, these smaller angles have to be complementary. So if I add them up, their degrees will equal 90. So I can do just that. I can say 90 equals this measure of this first angle, which is X, plus the measure of the second angle here, which is 35. So to solve for X, we will subtract 35 from both sides. And 90 minus 35, that will give us 55. So X has to be 55. In this example down here, again, I'm noticing that there is this right angle box. So this tells us that angle WXY has to be a right angle. So these two smaller angles inside have to add up to make 90 degrees. So I can say that if I add up the measure of angle WXZ, so measure of angle WXZ, plus the measure of this other angle, the measure of angle ZXY, together they have to add up to be 90 degrees. Well, we know the measure of angle WXZ is 35, so I can substitute that in place. And we know the measure of angle ZXY down here is 4x plus 7. And altogether, this needs to equal 35 degrees. Sorry, 90 degrees. Go ahead and combine our like terms because 35 and 7 are both constants. So 35 plus 7 will be 42. And we still have this 4x. Now we cannot combine 42 and 4x because 42 does not have that variable. So we have to just leave them be. So instead, we need to we can now work on removing the numbers that are on the same side of the equation as x. So 42 is currently being added to our variable term. So we can undo that with subtraction. So we can subtract 42 from both sides to cancel that out. So we're left with 4x, and over here, 90 minus 42, that will leave us with 48. At this point, we now need to remove the coefficient of 4. Well, 4 is being multiplied to x, so we can undo that by dividing both sides by 4. So when we do that, we'll get x equals, well, 48 divided by 4 is 12. So we get that x has to be equal to 12. The last type of angles that we are discussing today are supplementary angles. These are similar to complementary angles. However, instead of being two angles that add up to make 90 degrees, these are two angles who have a sum of 180 degrees. So we can see that in this diagram, we have an angle that's 120 degrees. That's angle HIJ. This plus the 60-degree angle, angle JIK, together will add up to 180 degrees. So we can say that those two angles are supplementary, or that angle HIJ is supplementary to angle JIK. Now, something else to keep in mind is that when we have a straight line or a straight angle, that angle is always going to be 180 degrees. So we can say that here the measure of angle HIK, this straight angle, that will equal 180 degrees. This is always going to be true when we have a straight line or a straight angle. We also have a special name for supplementary angles, so angles that add up to make 180 degrees, that are also adjacent or next to each other. In those cases, they are always going to be two angles that together create a straight line. So we call those special angles linear pairs. So in this case, angle HIJ and angle JIK together are a linear pair. So we can say angle HIJ and angle JIK are a linear pair because they create a straight line. If we have two angles that are not next to each other, they are not adjacent, however they still add up to make 180 degrees, we can call those supplementary angles, but they will not be a linear pair. A linear pair is specifically for two angles that together create a straight line. Now let's look at these last few examples here, working with supplementary angles. So first, we're asked to find the measure of the supplement of the angle. So that means this angle plus the other angle have to add up to make 180 degrees. So we can write an equation. 180 equals the measure of angle A, which is 113, plus x for the mystery measure. So we can subtract 113 from both sides, and we'll be left with x equals, this will give us 180 minus 113 is 67. So x, the missing angle, has to be 67 degrees. If the known angle is 20 degrees, then if we add that to the mystery angle, it needs to add up to make 180 degrees. So we can say 180 equals 20 plus our unknown x. So we can subtract 20 from both sides. And if we do that, we'll get x equals 160. In this example, we can see that we have two angles that together create a straight line. So that means they have to be supplementary. So they have to add up to make 180 degrees. So we can write an equation. 180 equals the known angle, 52, plus this mystery angle, angle A, so plus the measure of angle A. Well, we can subtract 52 from both sides, and we will get that the measure of angle A is going to be 180 minus 52. That will leave us with 128. So this angle here has to be 128 degrees. Next, we're asked if these two angles are or are not supplementary. So the way that we can check is to see if we add them up, if they equal 180. So we can test this, 83 plus 97. If we type this into the calculator and add them together, we will get that they add up to be 180 degrees. So this tells us that the angles are supplementary. So we can say that they are supplementary. Next, we're given this diagram. We're asked to find the measure of angle AED. So AED, if I trace that, I have AED. Well, if I'm comparing this to the angle that I know this angle here is 50 degrees. Well, we can go ahead and ignore half of the diagram, and we can see that BED is a straight line. So that means this 50-degree angle plus our mystery angle together have to add up to be 180 degrees. So we can write an equation where we say 180 equals our known angle of 50 degrees plus this mystery angle, the measure of angle AED. So we can solve by subtracting 50 from both sides. So we will get 130 equals the measure of angle AED. and we have our answer. Lastly, over here, we're asked to write and solve an equation to find the value of our variable. For this first problem, there is no x, but we do have a variable for y. Well, again, if we're looking at this, I can see that my angle, my 78-degree angle here, and this 5y plus 2 together create a straight line. So that means they have to be supplementary to each other. So we can write an equation, because if we add those angles together, they have to equal 180 degrees. So we can add the 78 plus this other measure, which is 5y plus 2. Well, we can combine our like terms first. So 78 and 2 are both constants, so we can add those together to get 80. So we still have 180 equals 80 plus 5y. Now we need to work to get the variable by itself. So we can easily remove the 80 by subtracting that from both sides. So we'll be left with 5y on one side. On the other side, 180 minus 80, that leaves us with 500. Lastly, to get y by itself, we need to remove the 5. 5 is being multiplied to y, so we can divide both sides by 5. 100 divided by 5 is 20. So we figured out that our variable here has to be 20 for this equation. And for number 12, again, if we're looking at this diagram, I can see I have one angle here, I have another angle right next to it, and together they create this straight angle, this straight line. So that means they have to add up to make 180 degrees. So we can write an equation, say 180 equals the two angles added together. So 6x plus 12x. Well, I can add those together, 6x plus 12x, that will give us 18x. So 180 equals 18x. Right now the 18 is being multiplied to x, so we can cancel that out by dividing both sides by 18. So we'll get x equals